and then we'll start doing that next Tuesday after the autumn break. So, who am I? Yeah, that's a good question. Actually, I started at DTU in 2007 in software technology. I've always been fascinated with the cross disciplinary IT projects, like crossing IT and something else. I think that is pretty fun. Right now I work in biotech as a software developer, where I do various biotech related applications, and I'm having fun with that. So while doing that, I'm also taking a master's over at IMM, the software and math department, in IT security, and I've also, on a hobby basis, done a lot of interaction development in a group called Labitat. I don't know if you know that. It's like a citizen lab, I like to call it, with electronics and software and interaction design and that kind of thing. Like trying to take out the more academic stuff and put it in a real world context. Not so much elitism and more hands-on and not so much report writing. and that is fun. So we've worked quite a bit with arduinos and built 3D printers and had a lot of fun. I'll also show you a demo in a couple of minutes about a project we did with an advertising company. And that's going to be fun. Okay, so I come from a software background, and I think that software is nice, or awesome for reasons we can discuss later. But designers tend to forget the programming that they once learned, and why is that? Because I'm going to say that you will need it when making functional prototypes. So we should probably do something about that. So I've put some questions on the slide. Because I believe that the majority of you would say that you've forgotten everything you learned in Java programming in your second or first semester. So why is that? Why is that? And I would like to hear your opinions too. Was it confusing, or was it boring, or didn't you understand the how it all hang sammen, hang together? I don't know. You have a.
Yeah, I found it frustrating a lot of the time, because you know that when your program or your code makes an error, when there's an error in it, it's because you have specifically asked the program to do something wrong.
Yes.
Ah.
Yeah, that is frustrating. You kind of have to learn the language of the computer, and if it's any support to you, this is going to be much easier than Java programming. It's going to be a lot of if-then. So if a sensor reading is higher than some threshold, then do something. So I'm going to go ahead and say that it is going to be easier than Java. So you can take a deep breath and just get started without even knowing what you're doing. So are there any more comments? How many of you are actually confident that you can still program? Just a show of hands. That is one. That is not a lot, considering how you are an entire class of students who have received programming education.
As a teacher, this is depressing, actually.
Yeah, but I have thought a lot about this actually, also in the mechatronics course. Why is it forgotten? Like, is it because you're not using it, or is it because you just didn't find it interesting? I don't know. But if you have any insights, I'm also going to be a teaching assistant in mechatronics next spring, so I could probably bring some of the inputs that you give me. I don't hate you, by the way, at all. Because I think it's pretty normal for design students to tend to forget that. So I think we should get started and talk a bit about what the Arduino is and what it can do for you as a designer of functional prototypes. Was there anything? No. So Arduino kind of be seen as the glue between the physical world and the world of computers and electronics. I don't know if that sounded a bit too I don't know, but really it is. It connects sensors to any kind of motor or output or light or sound or whatever that you might want to program, and does it in a way that you actually define. So you define why stuff is actually happening in the real world on the basis of inputs from sensors or computers or microphones or whatever. So in this specific case, you're going to add some logic, as we call it, to the dumb LED strip. You all got an LED strip per group, and you're going to add some logic, as we call it. Just make it alive. So this logic can be taken from buttons and sensors and computers and what have you. So I also want to say that Arduino is a real thing. It's not just something that we use at university. As I said, it is used by real people, and lots of people too. Actually, like it's you have textile engineers, like people who make clothing, that have started to actually investigate whether it would be fun to put electronics into their clothing. That there is electronically conductible fabric and thread and stuff like that, so you can Arduinoify the clothing that you use with sensors and lights and whatever. And so part of the Arduino's success is that the designer made an effort to make it easy to use, and that's where you're going to benefit. So Arduino has a large and diverse user base, and lots of community material, so you can actually, if you're just in doubt about something, maybe even Google it. There is a very, very large user base. Check it out on YouTube, what people have done. It is incredible. I've also seen I tried to find the picture yesterday, but I couldn't. I've also seen in CERN, like the particle accelerator, they used an Arduino for collecting data. So it's actually, like you can say, that's a stamp of approval, kind of, right? It's not just for fun anymore, and it's a pretty good skill to have too. Also, I want to say there's an active forum. So if you have problems that you cannot Google your way to, and for some reason you don't want to mail me, you can actually make a user on the forums and ask in there. And people tend to be helpful if you've done your research first. So I think we should take some motivational demos. And now it gets difficult because I have two screens. So here we go, and then on my home screen. This first demo is, as I talked about, the thing I was actually involved in with an advertisement firm. Can we have the sound on the PA?
Yeah. Here.
Yeah. So it maximizes to the right screen. It didn't. Hang on. This and then. Are you having a great day, by the way? And I'm going to like this. Okay, so I think it works now. Is it on?
Yeah, it's on the screen.
But also the sound.
I think so.
No, I don't think it is. But anyway, this was a campaign for Norwegian, done by this advertisement company that wanted some user interaction. So what they wanted was, it was like a marble run in a storefront window on Strøget in a window below. So you can see pictures here from this habitat. It's very chaotic and very like hands-on, and that's me. So we built the physical, you can say, marble run, and then we hooked together some software with the Arduino. Those are my hands on my computer, and built the thing. So the idea was that we should enable people to write an SMS to the machine that would then put a ball on the marble run, and then you could control it with your hands on the window like this. You can control a thing that does this, and maybe you won. So it was all backed by an arduino that controlled that motor and was listening to the sensors on the window, but also the sensors that would check if the ball actually hit the correct spot in order to win. And it was a lot of fun. So I don't know if I have any more to say. You can watch the video. Very like this, very like advertisement company-ish. Displaying all the mechanics instead of all the electronics and how fun people are having. But that's great. Yeah, so if the ball went through that pipe, they would win. They would remove the support from this, like this one, and then that would cut over a piece of wire, and then a sensor would do stuff, and they would get an SMS. But that's great. And what was my other thing? Yeah, that is another guy who hooked up a computer to his Arduino with a webcam, and that's just a kind of fun way to implement interactivity. Yeah, so we had a workshop with a very narrow curtain. Yeah, so he wrote some software that could detect where people were, and then yeah, so that's what he used. He probably used a programming language for computers called processing, which is basically the same language as Arduinos actually. So once you have learned and maybe even mastered Arduinos, you can try to write applications like this that actually talk to the Arduinos, and by extension put in much more intelligence, you can say, in terms of the inputs you can provide to the Arduino. Yeah. Oh, is it? Yeah, so he just hooked up. It's very simple actually. He just got the input of where people were in front of the window and hooked up a motor that could just adjust the curtain to follow people. Yeah. Yeah, so he closes his workshop again. Hang on. Just, yeah, I have to reset this because I have some notes on my screen. Let's see if this works. There we go. And where were we? Here we go. So let's see if I can write it. No. But yes, I also have a link to a group of people who want to make actually satellite orbiting the Earth. that you can rent for not a lot of money, and you could actually write Arduino programs that would get put onto the Arduinos that are orbiting around space and send back some information that you can get. And I thought it was maybe, was it $65 for 3 days of one Arduino? So they had a satellite containing a lot of them, maybe 50 Arduinos, and they could just allow people to run their programs orbiting Earth with sensors in space. That's pretty cool. So it has. I think this little thing has a lot of potential. It is really embraced by both the geeks and the designers and inventors and people who just want to tinker and kids and whatever. And that is pretty cool. So any sensor that you can actually think of, all of these, that's just a small set, can be used as inputs. But also, if you know how to program a computer, you can also use that, and that is also very powerful, as you saw before. Then we have other inputs are buttons and knobs, like you can make button stuff. But you can also, of course, hook up a lot of outputs, and I didn't really list them because to be frank, I don't think you could actually give like a realistic picture of the possibilities without sounding too you can say pompous. But imagine like light stuff, water, valves, sound, smoke machines, whatever you can turn on your electrical outlet. You have a lot of potential in this little thing, and that is pretty cool. Now I want to be a little more serious and talk about this programming thing again, because and this is not to sound arrogant again, but I really want you to give this programming thing a chance and not like abolish it from the beginning. So in order to use the Arduino, we have to learn some basic programming. We have to learn some basic electronics. And basic is really the key word here, because you don't need to know a lot about either to make something that is actually cool. I'm, for example, not very good at electronics, but yet I stand here. I usually get people to help me with the electronic stuff. So, as we talked about, I know some of you are alienated by the thought of actually having to talk to a computer and write a program. So, my take on this, as we talked about, is also I think that people get confused from the very beginning, and then they don't dare to ask the questions that would actually clarify stuff for them, and then it all gets on, and then you end up hating programming. So I don't want to sound arrogant, but please try to forget any a priori hesitation you might feel towards programming, because it can only hurt like like your own opinion actually. So we'll start from scratch, but still the scratch it will have to be, since we don't have so much time, it will have to be very compressed, which is also why we filmed this subject, so you can actually go home and rewind. And what else did I want to say? Yeah, so we'll discuss programming after the coffee break, and please try to ask all the questions that you might sit with. And there are no bad questions, stupid questions, because it's all about you learning this. So we're actually nearing the coffee break. I don't know if it's too early for that. But when programming Arduinos, you should think all the applications that you can think of with Arduinos can be formulated basically as a chain of if this then that stuff. And that is really, in order to really grasp what you're actually doing and to avoid being confused by it all, try to narrow it down to just this, if this then that. And another thing is you should let the software do the work. In mechatronics, I don't know if it was on purpose or it was an error, they had an exercise about switching on and off a light with the Arduino. and one group just used used the Arduino as the power source, and then the switch, and then the light. So they would actually switch the light. But that was not really what we thought about with this exercise. We wanted the Arduino to actually switch the light on the grounds, on the basis of the input of the switch. So it's actually the switch had to go through the Arduino and then switch the light, and they didn't do that. So that might sound actually more advanced than what we actually want to attain, like the Arduino switching, just the lights being switched. But it's actually less advanced, I would argue, because by having the software do the work of the switching, then you will have only one place to look for the eventual error you're going to get, and it might, it will be clear to you in a minute. So actually now I thought we should have a coffee break, but I don't know if is it too early? Yeah. Okay, so I have this stupid coffee machine again. I don't know how many times you've seen it, but I want to talk a bit about what is inside such a machine. Have you talked about that with Ali? Yeah. So what is in it? What is in it, like electronically? What kinds of sensors? What inputs and what outputs do you have?
Buttons and inputs.
Yeah, you have buttons. You have all the buttons here, and they talk down to the Arduino that's inside. If it's an Arduino, I don't think it is, but let's just assume it is. So you have buttons. What else do you have? Yeah.
You got a sensor down at the cups, so you can detect if there is anything.
Mm-hmm. Yeah. Good.
There's also a sensor in the tray to detect liquids flow.
Okay, I didn't know that.
Usually,
Okay. Yeah.
There might be a heat sensor to regulate the temperature of the water.
Yeah, I think so too. I think there is like just a water boiler inside. I don't know actually. I'm just guessing. I have a list of stuff on the next slide. Well, what else do we have? Do we have valves of any kind? Do we have like it has to have a water supply, right? So it probably has a valve too that is controlled by this Arduino stuff. So if I press, this is simplified. If I push the button, then we'll probably open the valve for the input of the machine, so it takes in some water, and start up the heater, and maybe do something with the dosage of the coffee powder that's inside, and then pour it into the cup. So you can actually even a big appliance like this coffee vending machine can actually be you can say deconstructed into these if this then that things. So yeah, I'm going to say that aside from the card reader stuff, you'd be able to make such an appliance at the end of the course. The idea is to assemble simple parts into something that is complex, and that is all tied together with the Arduino. So all of this is good news. So and we're doing programming from scratch, and now comes kind of the bad news, because we don't have all the time in the world to learn it. So we will have to make a very dense programming presentation after the coffee break, which we just had. And learning how software and electronics can interact, hopefully while having fun. So let me see. Yeah, there will be some simplifications and cut corners as well, because we simply won't have time for it all. But my suggestion is that you can find Arduino beginners tutorials to supplement this talk, and you can find them online. And you can also look at CampusNet. There is a book in the files sharing about like beginning with Arduinos, and it is written for designers actually. So you might have a look at that. So what we're going to do is that we're going to introduce the Arduino. So this Arduino machine has a lot of these pins, as we call them. I don't know if you have your Arduinos today, but it has these like rows of black bars with holes in them. And they are called pins, and that is the interface that the Arduino uses to talk to the world. There are different kinds of boards, and you have like a mega board, and they all have different kinds of pins. So if you want to simplify it, you could say that the more pins it has, the more things it can actually talk to and do at the same time. You have a mega, and that is probably more than you need. But anyway, there are also different types of pins. There are both these digital pins and analog pins. And aside from that, there is also input and output you have to know of. So digital pins are, as I wrote, for communication and stuff that you can actually turn on and off, like lights and stuff. You're going to interact with your LED strip over a digital pin. Analog pins are used for stuff that is not necessarily on and off, but can be somewhere in the middle. A sensor says the room is this hot, or there's this much light. It's not a 1 and 0 thing. So that is what analog pins are used for. If you use analog pins for output, you can actually make sound, because sound is also kind of not 0 and 1, but somewhere in the middle. It's waves, you know. And that is kind of a simplification, but good enough. Good enough. So Arduino programs consist of 2 parts, and that goes for all Arduino programs. There is a setup part and a loop part. So the setup parts is run exactly once. It is setting up what needs to be set up. The Arduino needs to know if a pin is used at all, or if it's input or output. Oh, and what some other stuff you could think of that needs to be done when the Arduino is booted and not anymore again. So you can use the setup. You'll have these slides as well, so you don't have to take a lot of notes unless I say stuff that isn't on the slide. By the way, so as I said, the setup is run exactly once, and loop is doing what we call the business logic. It is doing the same thing over and over. It might be reading a sensor, doing something with that input. It might be listening for what a computer has to say and controlling the 3D printer from that. It might be whatever, just something it does over and over. And yeah, there's also a trivial example, like if a sensor reading is too high, you can raise the alarm. I don't know what raising the alarm could be, but that could be turning on an actual alarm, blinking some lights. I don't know. But think about it as an if this then that thing. That's an important lesson. Okay, so we're going to look at maybe the simplest program that you can think of, and this is it. It is very short. So we have the setup and we have the loop parts. You can forget these void keywords in the beginning for now. It is something to do with stuff you don't need at the moment. So just focus on all the other things than the void. Okay. So the setup part, as I said, is run exactly once. It sets the pin mode of pin number 13. That is just a number. You can see it on the board which numbers the pins have.